Welcome to our presentation on the impact threat, created by Simran, Diana, and I. Introduction to the impact threat. The impact threat refers to the possibility of a celestial body colliding with planet Earth. These near-Earth objects, such as asteroids and comets, vary in sizes from a few meters to several kilometers in diameter. Scientists monitor the skies to detect and track these near-Earth objects, to study their orbit, and to mitigate risks of potential impacts. This is part of planetary defense. These efforts consist of observations, orbit determination, and impact hazard assessments. There's a catalog of kilometer-sized near-Earth objects, and several observatories are dedicated to monitoring and detecting these near-Earth objects. The first near-Earth asteroid discovered was Eros in 1898 in Berlin. Since then, survey programs have been discovering near-Earth objects. Linear alone has discovered 230,000 asteroids and approximately 300 comets. Although comet impacts are possible, the great difference between the number of asteroids and comets leave it at approximately 1% of the total impact risk, which is extremely rare. Because asteroids are more likely to pose an impact threat, we'll discuss them. So an asteroid is a small rocky or metallic object that orbits the sun. They're the stuff that never made it to becoming planets in the early days of the solar system's formation. They vary in size, with some being just a few meters across, while others can span hundreds of kilometers in diameter. They're primarily located in the asteroid belt, the space between Mars and Jupiter, close to the frost line, which makes them closer to Earth than comets. Different discovery surveys detect asteroids and comets, but most of the near-Earth objects are asteroids, which is why they're called near-Earth asteroids as well. They're closely monitored due to potential impact threat. All information gathered about asteroids are sent to the Minor Planet Center, where data is compiled. The MPC then determines whether the near-Earth object is a potentially hazardous one, which is an object that could potentially strike Earth. The status of it being hazardous is determined based on the orbit of the object. The Earth Minimum Orbit Intersection Distance, MOID, is determined, and if it is less than 0.05 astronomical unit, then the object is declared a PHA or PHO, potentially hazardous asteroid or object. Because asteroids that are 1 kilometer or larger have a potential of causing greater disaster, in 1998, the U.S. Congress tasked NSA with discovering and tracking more than 90% of the 1 kilometer or more sized near-Earth objects. As of February 8, 2023, the catalog is around 95% complete. What are the possibilities of a large asteroid hitting Earth in our lifetime? So before all these surveys and the cataloging of the near-Earth objects and their orbits, the odds of a person dying from an impact threat was thought to be similar to a plane crash in the United States. That is 1 in 20,000. However, the outcome of discovery surveys has reduced the odds to 1 in 720,000 for a person with a life expectancy of 80. To put this in perspective, the odds of dying in a fireworks accident is 1 in 600,000. This is because larger diameter objects are less than we previously thought. So, what are the chances? Slim. At the moment, there are no potentially hazardous objects that could impact Earth. Consider this. The NEO, near-Earth object that resulted in the extinction of the dinosaurs, occurred some 65 million years ago. The largest known crater on Earth, the Fort crater in South Africa, that's 2 billion years ago. The chances of a large impact threat, well, maybe in another century or two, but certainly and most definitely not in our lifetime. Collision effects. There are certain factors that play a crucial role in what the effects of an impact would look like, such as the object's size, mass, and the location of the impact. The mass determines the kinetic energy of the impact. The location is important because impact on land would create a crater, and in the waters it would create a tsunami. An object with a diameter between 1 to 10 meters would explode in the atmosphere without a direct impact. It's called airburst. However, imagine a massive asteroid around 10 kilometers in diameter, like the one that caused the extinction of dinosaurs. Something like that would be catastrophic on a global level. The first moments after the impact, there would be massive shockwaves from the release of the energy equal to millions of hydrogen bombs. Let me put this in perspective again to understand just how devastating it would be. It was the discovery of a high amount of iridium on the Earth's surface that allowed scientists to conclude that the extinction was caused by an impact threat. This was also what helped determine roughly the size and mass of the near Earth object. It was about 10 kilometers across, with a mass of 1 trillion tons. The collision generated energy equivalent to 100 million megaton bombs. Hiroshima during World War II was the result of 13 kilotons of nuclear bomb, called Little Boy. The strongest hydrogen bomb, the Tsar bomb tested by the Soviets, was 50 megatons. This means that the impact of that explosion would have been 20 million times more powerful than the deadliest hydro bomb detonated in human history. For those that survived this immediate shockwave, a series of events would be triggered, like earthquakes, tsunamis, volcanic activities, and such. Now, the layer of dust and ash particles that covered the Earth will turn day into night, the darkest of nights. This would stop photosynthesis, effectively killing plants, and animals would starve. There would also be no solar radiation, so for those that do survive all of that, they would freeze to death, letting a new ice age come in. The only survivors would need to burrow for food and shelter, like small ferret mammals did back then. What are the efforts? Scientists around the world are constantly observing and detecting near-Earth objects. The Earth's planetary defense system provides forewarning based on the observation predictions, which allow for months, years, even decades of planning a response to an impact threat. There have been several initiatives like NEAT and Linear that have discovered and contributed to planetary defense by detecting and cataloging near-Earth objects. NEAT, short for Near Earth Asteroid Tracking, was a discovery survey jointly run by NASA, the Jet Propulsion Laboratory, JPL, and the U.S. Air Force from 1995 to 2007. NEAT discovered approximately over 20,000 objects, with around 430 being near-Earth objects. And Linear, short for Lincoln Near Earth Asteroid Research, began operating in 1998. It was a joint project between the United States Air Force, NASA, and MIT. It discovered over 230,000 asteroids and approximately 300 comets. But scientists aren't just sitting and observing these near-Earth objects. They're actively figuring out ways to deal with potentially hazardous asteroids. In fact, in 2002, NASA's Double Asteroid Redirection Test happened. DART became the first mission to test a method for deflecting near-Earth objects successfully by altering its course. The target was Dimorphos, the smaller of a binary asteroid system, with an orbit time of 11 hours and 55 minutes around Didymos, the main body. The mission was to lower Dimorphos' orbit. The asteroid was chosen because it was smaller of the two asteroids orbiting each other as they orbit the Sun. They also posed no threat to Earth even if it was knocked off their current trajectory, as it was 11 billion kilometers away from us. Also, their course had been observed for some time, so any changes would be a result of DART. The success of this test allowed the scientists to check the accuracy of their predictions and models on asteroid deflection. Worried? Don't be. It's true that massive near-Earth objects are an existential threat, but unlike the unfortunate dinosaurs, the human race has initiatives, space programs, and the ability to rationally deal with potential threats. Despite the many challenges humanity faces, the possibility of an impact threat should not be ignored. While the chances are low, the consequences are devastating. By investing in scientific research, planetary defense, and international collaboration for early detection and mitigation, we can ensure the safety of our planet. Allocating necessary resources towards understanding and addressing potential hazardous objects is essential for protecting future generations and safeguarding the planet. Also, considering the possibility that an impact threat is rare, it doesn't make sense to worry. We're facing dire situations in global politics, and it seems that before an impact threat could destroy humanity, the world leaders are determined to break out into a nuclear World War III. So remember, the possibility of you or I dying from an impact threat is 1 in 720,000. At this point, we're more likely to die from a war breaking out. Thank you for your attention.